Okay, then our last installment that we were looking at this home and how we were doing things, I think I was standing on compacted crushed 1-inch gravel. Since then, it's only been like 6 business days. We've really moved along, and you'll be able to see that some serious things have changed. Starting with the concrete floor. Now this is the concrete floor, your basement floor. This concrete was poured over that crushed rock, and it is 4 inches thick in concrete. They smooth the finish out, and then they put a sealer on it, so it makes for a slick finish. The reason we use the sealer is to slow down the curing time of the concrete, and it makes for much fewer cracks. Unfortunately, concrete does 2 things. It gets hard and it cracks. But we do what we can to limit those cracks and put them in specific places. Example here, we have done a saw cut. We cut an expansion joint in this concrete floor here using a concrete saw, and it's cut down in there about 3 inches thick. Not all the way through, but about 3 inches thick, so that the cracks from the expansion of the concrete, it's going to tend to crack here. And if it cracks in this controlled area, it doesn't look unsightly. But concrete will crack no matter what. And sometimes even if you give it a place to do its dirty work, it still tends to crack anyway. So if you see cracks in your basement floor, don't be alarmed. As long as there is no change in their plane, the crack in the basement floor is not considered a flaw and not something for you to worry about. Now, if one side of that concrete is higher than the other, that means there's some movement going on and there's something wrong. But this concrete floor was drilled in and pinned into the walls and poured, and it acts as a part of the foundation. This system all works together to keep these basement walls from moving in or moving out. It's a little bit different than what some people do when they pour their basements, and they separate the walls from the basement with like a piece of plastic for expansion around the edges. When they do that, though, it's not working together as a system. They're independent of one another, and we certainly prefer to see it all work together. When we pour a standard basement, unlike this is a walkout basement, but when we have a standard basement, all this working together and tying together makes one giant box, and that could literally float like a barge if you put it in the water. It'll hold together that way. And in our last installment, you saw the pier pads. They were large concrete piers that were surrounded by gravel, and the pier pads' location are relevant to these posts. These posts are sitting on top of a concrete floor, but underneath it is that large concrete pad, and that's what dissipates the weight from the steel beam above. Now we use an adjustable post, an adjustable steel post, and the adjustment's down here on the bottom, which allows us to fine-tune the elevation of the floor above. And the floor joists are set using a laser level to make sure that the subfloor itself is perfectly level. When you walk into one of our homes and you place a marble on the floor, it stays put. It doesn't run across the room because the floors are perfectly level. Above this steel post, you'll find a steel beam. This is an 18-pound steel beam, 8 1/4 inches in height. Extremely strong, and it's supported every 12 feet from post to post. I have a post here, right at 12 feet. Further away, I have another steel post. This far exceeds what's required for support on the steel beam system here. Now that steel beam is tucked back into that beam pocket. It goes into that beam pocket 3 inches. There's just about a 1/2 inch slack on each end so that it can't come out. It can't fall out, can't be knocked out, nothing like that. But these posts, they get Tapcon screwed with special concrete screws. We call them Tapcon screws, down into the concrete floor so that they can't move left or right. You can't bump into them and shift them in any way. Now we started our framing process. We're framing the rear wall, and if you can pan over this way, we'll show you something about this. Here we have the mud sill that sits on the concrete wall, and then you have the first plate, then you have your studs, and then you go up to the top plate. Now we've sealed this bottom sill with a foam, an expandable foam, to make sure that the air stays out. We don't lose any air back and forth. We make these homes just as airtight as we possibly can. And above the top plate, we have the rim joist and the floor joist. And in a few minutes, we'll go upstairs and we'll stand up on the upper level so we can talk about the floor joists that we use. And they're very special. We really like them. We think quite a bit of them. And over top of the door opening, you'll see here's a header. All the headers that we utilize are 2x12 headers. And there are two pieces of 2x12 that are coupled together. Building code only would require us to use one, but why use one when you can use two? It's twice as strong. And you're going to have far fewer problems with things settling and moving. And this 2x12 is set over top of a jack stud. They call this board here a jack. I'll step to the side and just illustrate it. This is a stud. This is a jack. Notice that the header is sitting on top of the jack, so its force, its weight, is distributed downward and placed right on the concrete wall. From where Ryan's looking, he can show you that it's not by accident that where you have a stud above it is where the floor joists are placed. We call this stacking, or loading things in a stacked manner. It's not required by building code, but it is good practice, so that all the weight from the roof that gets transferred to the floor joist is transferred straight to the truck or to the stud and down to the foundation where it belongs. Things don't buckle, they don't move. Now, unfortunately, this home is so wide that you could not get a steel beam as long as this home is and get it down the road. The trucks just can't carry it, so it's brought in pieces. And whenever we have a splice for a steel beam, it's done over top of a post. And in this steel beam, it's actually spliced together with splicing plates and bolts run through it on both sides so that they cannot come apart. And that'll stay together forever without a problem there. So now I'm going to go upstairs and look at the floor joists, and we'll talk about that for just a